Tonight and taking valuable family time, dinner time to spend it with us and Dr. Davies and our panelists. Before I get going with anything else, a little housekeeping. For any of you who have ever seen a presentation here at Battle Mountain High School, you know they're about to replace all of their kind of AV equipment. The AV equipment here, the audio, has a real challenge with mobile phones. So what I'm going to ask you all to do right now is reach for your mobile phone. Don't silence it, but rather shut it all the way down or put it in airplane mode, making sure that wireless, telephone, and Bluetooth are all disabled. So now I can talk to the real stuff, too. Let me tell you about really how we got here tonight. The town of Park City, Utah, held an event back in October called Mountain Towns 2030. It was a climate event, and it was meant to discuss the particular challenges that we face in our mountain resort communities, and also the opportunities we have to address climate change and how we deal with resiliency and other things. There were a number of us from this community in the region. It was all three Wheat County commissioners, our Sustainable Communities Director, Adam Palmer, Mayor Sarah Smith-Himes from Avon, Avon's manager, Eric Heil, Christian Bertulia from the town of Vail. And actually, we have a number of people. We are coincident with the Colorado Association of Ski Towns is in Avon the next couple of days. And I know a lot of those people were there as well. So it was a lot of regional representation at that. So at that event, the first speaker we heard was Dr. Rob Davies, Dr. Robert Davies, who you're about to hear in just a moment. And I think if you look at us all as choir being at that event, that you'd probably expect us all to finish off like nodding, say, yes, it's a problem, we're working on it. But I think to a person, we were stunned, and we were excited, we were energized, and it was that energy which was very peculiar because, you know, it's a climate reality presentation, but Rob will talk about in his presentation what he says gives you clarity. And it was really that clarity that I think, oh, you didn't get the phone message. Can you pass that on to him? It was really that clarity that, that left us very energized. And then there was a bathroom break, I think, after Rob's presentation, and then we all sat in the front looking at each other from our community going, now what? And the first answer to that question now has become this. We need to get Dr. Davies to our community so that he can give what we have seen, particularly to our community's leadership. That's you. Because the next answer to the what next question has to come from all of us. So we'll talk more about that after we hear from Dr. Davies. So let me tell you a bit about Rob. As a physicist, Rob's training has been in atmospheric physics, surface physics, and quantum optics. One of those I've heard of. But his work for more than a decade has been in critical science communication, principally focused on global environmental change and sustainable human systems. His work in these areas has been recognized for more than a decade in critical science communications. Dr. Davies has delivered hundreds of public lectures to civic organizations, policymakers, municipal boards, and schools on the topics of climate change, human sustainability, and science communication. I could say a lot more, but what Rob has to say is probably more important. So please join me in welcoming Dr. Robert Davies.
Please replace the lamp. As we move forward, I think we should regard this as a message from the universe to us tonight. So thank you very much for the invitation to your community and for all of the work that you're doing here. The Climate Action Collaborative is really doing some amazing work, and we'll talk about that, I'm sure, as the evening goes on. As you heard, my training is as a physicist. And I've done a fair number of things as a physicist. And at one point, a friend of mine once told me, Rob, you're becoming so well-rounded as to be pointless. But it turns out to have been the perfect training for what I've been doing for the last 10 or 15 years or so, which is synthesizing a really broad range of human knowledge from the standpoint of understanding what we are facing as we move forward. So what I study, as you just heard, is global change and complex systems, and in particular, the interactions between human systems, food and energy and economy, with the Earth system, our life support system, with soil and water and climate and life. And even more particularly, the implications of these interactions for us in the coming decades as we move forward for our well-being, our vibrancy, and our sustainability. And what we're going to find out, and I think won't come as a surprise to many of you here, is that we are experiencing massive and growing disruption of our life support system from human systems. So much so that we now have to actually redefine in our minds what it is we consider radical. And we'll come to that a little bit later on. But it's going to be a theme that I think is going to be important, certainly from my perspective as we move forward. Now, ostensibly, we're here to talk about climate change in particular, arguably the most acute of our disruptions of the planetary system. And a lot is happening, and you're all figuring out as a community how to move forward. You have a climate action plan coordinated by your Climate Action Collaborative, and a lot of work has gone into that. These things don't just happen. In fact, events like tonight don't just happen. They involve a lot of organization. That only happens with really dedicated people. I suspect most of you know the basic story of climate change, and so I won't spend a lot of time on that in particular. I will review it. But we're not going to talk specifically about the detailed science of climate change. What I actually want to do is, as you move forward as a community, help you establish a scale of the risks that we're facing and a scale of the response that is required of us. Place that response into a broader context. And at that point, I think it's going to be pretty heavy. I think you all suspect that bit. And I'm going to apologize right now, and this is no joke intended. You're going to say, well, nobody invites that guy to parties anymore. And I'm going to apologize because this is not easy information. But it's important that we take a good, straight look at what we're facing so that we can move forward. And so what I'm then going to do, what I'd like to close with, is to just put forward a mindset for you to consider for us to move forward and accomplish the response that is required of us. And with this mindset, then, an extraordinary opportunity that we have. So let's just first review this notion of climate change, or disruption of the climate system. The basics are this. As a fully globalized now industrial society, we emit things into the atmosphere, particularly carbon, and most importantly, carbon dioxide. Those emissions we will measure in gigatons, billions of tons of carbon dioxide. You'll need that for a little bit later. Write it down. And then, of course, these emissions build up in the atmosphere. The concentrations of carbon in the atmosphere build up. Not all of it that goes into the atmosphere stays there. About a third of it stays there. The rest of it, a third goes into the oceans. About a third is absorbed by land systems, vegetation. But it builds up in the atmosphere, and we measure that concentration in parts per million. So how many carbon dioxide molecules, for example, for every million other molecules in the atmosphere. And on that, then, our atmospheric concentration of carbon dioxide looks like this over the last 1,000 years or so. So 1,000 years on the left, basically today over on the right. This is parts per million on the left. And you can see that for most of the last 1,000 years, indeed, I could show you more, most of the last 12,000 years, we've been at about 280 parts per million. But then at the beginning of the industrial age, in earnest in the 19th century, you can see it starts to rise. And then in the middle of the 20th century, you can see there where it really takes off to where we are today, which is 410 parts per million. This is important because carbon dioxide is a very powerful greenhouse gas. And greenhouse gases, because of their molecular structure, are able to take energy that is leaving the Earth system in the form of light, mostly infrared light, absorb that energy and convert it into thermal energy in the atmosphere, heat. This is what they do. The physics equation that tells me that a molecule of carbon dioxide will absorb a certain color of light and turn it into heat in the atmosphere is the exact same physics equation that allows us to build things like this. No moving parts. It's the same physics that allows us to take pictures of our planet, from the edge of our solar system. So we understand this very well, and the result then is that we're warming up. And this is what that warming looks like over the last century, from the end of the 19th century to the middle of the 20th to today. I'm going to show this to you again, and as the different places on the map go from the cooler blues to the warmer reds, that's those places warming up. So this is a map of temperature change, not temperature. The North Pole didn't suddenly get warmer than the equator, but it is warming up faster. End of the 19th century to the middle of the 20th to today. You can see the entire planet is warming. You can see the warming is most definitely not uniform. Land surfaces warm faster than water surfaces, and the high latitudes warm faster than the equator. But if you average it all together, you find out that the global average warming over the last century is a little over 1 degree Celsius, most of that occurring in the last 40 years. And for those of you who are metrically challenged, you can always convert a temperature change from Celsius to Fahrenheit by roughly doubling it. 1.8 is the specific conversion factor. So that's about a 2 degree Fahrenheit global average temperature warming. And that doesn't seem like a lot to us. The temperature changes more than that as we walk out into the hallway. But you're going to find out in a moment that this is a really large, fast temperature change for the Earth system. So this anthropogenic human-caused global warming is disrupting the entire planetary climate system. Everything is connected. When you change the temperature, you change everything else. And I think many of you know from basic science classes that or just gardening, as you warm the temperatures, you warm the air, roughly speaking, it can hold more moisture, and so evaporation intensifies. So warming the air draws more moisture up into the atmosphere, but then when you do get a storm, the precipitation is more intense. There's more water up there to come down. This intensification of the hydrologic cycle or water cycle is a very big effect of warming the atmosphere and has been documented very well over the last 40 years on every continent. And if that were the only impact, it would be enormous, but it is far from the only impact. Everything is connected. When you change the temperature, you change conditions, for example, for the cryosphere. This is the frozen bits on the planet. The continental ice sheets like Antarctica and Greenland, mountain glaciers, frozen soil like tundra, frozen sea ice, the polar ice cap, the Arctic Ocean. You change everything there, and not surprisingly, it is melting. When you change the temperature of the planet, you change internal redistribution of the energy of the planet. Our weather patterns, for example, here in the northern hemisphere, in the mid-latitudes, most noticeably and importantly for us, we're changing the fundamental nature of the jet stream, which is the major storm track for us here in the mid-latitudes. It's slowing down and it's getting wavier. And the jet stream is kind of the boundary between the warmer tropical air and the cooler polar air. And as that jet stream changes, it changes where the storms go, where it rains, where it doesn't, where it snows, where it doesn't, the intensity of heat waves. It changes how far north you pull equatorial air and how far south you can push down polar air. It changes everything about these weather patterns. We change even internal climate cycles to the planet, the best known being the El Niño-La Niña cycle, which is about exchanging energy between the oceans and the atmosphere. We change everything for the biosphere, the living bits on the planet, where things live, where they don't, when they migrate, when they don't, when they go dormant, et cetera, et cetera, et cetera. Here in the mountains, of course, things are changing really dramatically as species move upwards in the alpine environment to try to maintain their preferred climate. We change fundamentally soil chemistry, atmospheric chemistry, ocean chemistry, lakes and rivers and streams. Absolutely everything changes. So this then is what we mean by global climate change. Anthropogenic global warming is driving global climate change. So the story then is Earth is warming because of us. And I'll say that we can quantify how much of this warming is because of us. It's between 90 and 120%. probably closer to 120% than 90%. And the reason I say that is because without the human tug on the climate system, it turns out that Earth would actually be cooling a little bit. But the human tug on the climate system is now so strong it has swamped all natural tugs, and we're warming instead. This anthropogenic global warming is disrupting the entire planetary climate system. And the final thing that we know, and that we move forward with tonight, and why we're here, is because if we continue on the track we're on now, it carries with it extreme risks for humans. And so this is what we're going to talk about now. When I say extreme risks, what do I mean? So let's talk now about the scale. The scale of the risks and the scale of the response that is required to meet that risk. So let's start with the risk. We can run projections using climate models. And in this context, the term model means physics, not climate physics, just physics, applied to the climate system. But again, I'll say it's the same physics that allows us to do everything else we do technologically today. And when we apply that physics to various scenarios, we can try to project forward what do we expect the climate to do. And under a high carbon scenario, which is the scenario we're currently following, meaning that we're still continuing to pump large amounts of carbon dioxide and other greenhouse gases into the atmosphere, this is where we can expect to be by the year 2100 with an additional, call it 13 degrees Fahrenheit, average warming across most of the lower 48. And as you look at those darker reds up towards the pole on the right-hand picture there, that's 25 degrees Fahrenheit of warming at the poles. What you're looking at the right is a completely different planet than we live on today. On the left is a projection using a low carbon scenario if we were to sort of get religion right now. We can still expect an additional 4 degrees or so of warming across the United States, the lower 48. This is a bit more than we've already experienced. And so what you're looking at in these two scenarios is a choice. We actually get to choose which of these scenarios we move to. On the left, the scenario on the left still carries with it rather large amounts of adaptations that are required and very large impacts to both human and natural systems. It is by no means trivial. But the scenario on the right is a completely different planet. And the scientists who study all facets of how this plays out with our human society, from social scientists to military planners, to physical scientists, refer to the scenario on the right as catastrophic. And they're using that term very precisely, and by that they mean catastrophic for humans, they mean unadaptable for human civilization. That's the risk that we run. There's one more thing I should tell you about these two scenarios, that if we are following the scenario on the left, by the end of this century, that's where we should be leveled off. That's the change then that we have to deal with as a species and as a civilization moving forward. If we follow the scenario on the right, it's very likely that is not where we end up. We continue to warm for another 1 or 2 centuries, and large changes continue to occur. That's just where we cut off the simulation. Let me put this in terms that those of us in the West really understand, which is snowpack. So here's snowpack in 1950 at the spring. This is when snowpack's at its maximum, really to start melting and giving us the water that we use for the rest of the year. In Utah, where I live, most Utahns get most of our water from melting snowpack. I suspect it's a similar situation in Colorado. So what we're going to be looking at is this in this data and simulation. Of course, the darker blues are the deeper snowpack. That's the higher elevations. The whites are the thinner snowpack in the lower elevations. And I want to show you some data starting in 1950, and then projections moving forward to the end of this century under, again, a high carbon scenario, which is the track we're currently following. So here's the data, and you can see that some years are snowier than others. We know this. But we always have significant snowpack, and of course we've built our society here in the Mountain West around that. By the time you get to the middle of the century, you find dramatically thinning snowpack under projections. And by the time we are in the latter half of the century, of course, the snowpack is all but gone. And this is not too hard to understand. As the temperature warms, more of our precipitation comes as rain than comes as snow. And so we're no longer storing that. This, in and of itself, is an enormous impact to our regional communities. One more I want to show you is soil moisture. This includes projections that talk about temperature, which drives evaporation, and precipitation. And under these scenarios, it's interesting. You can find yourself in sort of a perverse situation where you might even get a little bit more precipitation and still end up drier. And that's because, again, as the temperature goes up, the evaporation intensifies quite significantly. So this is a simulation for soil moisture under a moderate emissions scenario, somewhere between getting religion and not. As the places on the map get browner, they get drier. As they get bluer, they get wetter. So this is what it looks like through the middle of the century, quite significant drying. More drying as we move to the end of the century, but it started to taper off as the carbon emissions, as our emissions go to zero and as the concentrations in the atmosphere stabilize. I want to show you this projection again under a high carbon scenario. Again, this is the path we're following. Drying through the middle of the century, again quite significant, and then dramatically intensifying by the latter half of the century, and then continuing. As I told you, this isn't where it ends under a high carbon scenario. Now, I haven't given you any numbers here, but let me again tell you that the people who study this, again, from military planners to social scientists to agronomy scientists, farmers, et cetera, et cetera, et cetera, refer to the situation on the left as dangerous, again requiring quite significant adaptations and significant impact to our society, and the situation on the right is catastrophic, again meaning unadaptable. To maybe drive that home, you can understand sort of quite obviously the problems with dramatically drying our soil and having no snowpack and these radically increased temperatures. But many of the most significant impacts, of course, aren't quite obvious to us. And I just want to make that point with the following graphic. So we'll just connect the dots on this graphic. Each dot represents a community in the world on a coastline with a population of 1 million or more. On our current path, we expect to see as much as 2 meters of sea level rise by the end of this century. 2 meters of sea level rise displaces 200 million people from where they currently live. 2 meters of sea level rise sees 600 million people flooded annually through storm surges and high tides. So when we start to think about the implications of dramatically altering our environment this way, it's not just the obvious implications. But think about what the chaos that has been sowed across the Middle East and North Africa and into Europe over much of the last decade, as something on the order of 5 to 7 million people have been displaced from their homes from political strife in the Syrian civil war, which has a very strong global warming fingerprint on it. In the 4 years preceding the Syrian civil war, there was a dramatic drought that drove many people off the land into the cities in a society that was already stressed. And of course, it collapsed into this absolutely tragic humanitarian crisis. And then across northern Africa, disrupted weather patterns that mean that the inhabitants can no longer grow the crops that they've been able to grow for many, many centuries. People have tried, more than 1 million people have made their way into Europe, and so just complete, utter political chaos as a result. That's from 5 to 7 million people being displaced. Now imagine tens of millions to hundreds of million people being displaced. And this, we start to understand why the United States Defense Department has issued more than a dozen reports in the last 2 decades calling climate change the single largest security threat that our nation faces because of the political chaos and disruption that it sows from displacing so many people. So as we consider the scale of the risk that we're facing moving forward, things like the displacement, mass displacement of humans, dramatic impacts, particularly to our food system, to our water system. This then is the kind of data that people are looking at and the scientists look at when they issue statements like this, and this is an absolutely mainstream scientific opinion from the large community of scientists who study this, not only the climate scientists, but the social scientists as well, who look at what are the implications for these changes. So this is Lonnie Thompson, quite a distinguished glaciologist at Ohio State University, saying this is an existential threat to human civilization. Kevin Anderson, the deputy director of the Tyndall Climate Center in the United Kingdom, who himself is quite an accomplished carbon modeler, he looks at carbon scenarios moving forward and how we might navigate this, says that a 4-degree future is incompatible with an organized global civilization. What he means by 4-degree future is 4 degrees of global average warming above pre-industrial temperatures. And remember, we've already warmed about 1 degree. Incompatible with an organized global civilization. Likely to go beyond adaptation. This is the catastrophic definition. Devastating to a majority of ecosystems. And a high probability of not being stable. And it's this one that I want to just spend a little bit more time on. Earth's climate system, like most complex physical systems, is what we call nonlinear. And that means that it's twitchy. You can poke it a little and it changes a little. You can poke it a little, it changes a little. But if you poke it just a little too much, it exhibits nonlinear, very, very dramatic behavior. You can get a big change. And we know that this happens in the climate system. Indeed, it's the story of the last several million years worth of glacial cycles and interglacial cycles, which I'll show you in a moment. So by studying this paleo, past climate data, we can identify what we think of as tipping points in the climate system. Indicators that say the last time it was like this, things were quite dramatically different on the surface of the Earth. And one of those is, again, the concentration of carbon dioxide in the atmosphere. Remember this picture. What the paleoclimate data shows is that the last time we were above 350 parts per million for any significant amount of time geologically, meaning a few centuries or maybe 1,000 years, sea levels were nearly 200 feet higher. This was an ice-free planet. Now, we've already well passed 350 parts per million, so that this piece of data suggests we don't want to stay above 350 parts per million for very long. The implication is that there are feedbacks that will kick in the system that will take us to a very dramatically different place. We often visualize this notion of stability with the following picture, with this marble sitting in a dimple. And again, if I disturb it a little bit, the forces around it tend to take it back to where it was. But if I disturb it too much, it can cross thresholds or tipping points that take it to a dramatically different place. And this, of course, is what we're quite worried about. This is the notion that, and once you cross that threshold, the likelihood that you can return to that state that you want to be in, our current state, to which human civilization is very highly tuned and adapted, is essentially zero on any kind of a human time scale. So this is the scale of risk that we're facing. And once you cross that threshold, again, it becomes, the chances of going back become dramatically reduced. We don't know exactly where these thresholds are and precisely what they are. The data, though, suggests from the modeling that we're pretty close. And in this case, of course, from a risk management standpoint, this uncertainty is not our friend. When you don't know where the edge is, you want to stop well before you get there, if the consequences are big. This is, I mean, I think by any consideration, a meaningful definition of risk management. So it's kind of like the film. I mean, you've all seen the Titanic, I imagine most of you have, which is the perfect metaphor for all things catastrophic, right? But there's that point in the movie when they've hit the iceberg now, but it's this glancing blow, right? It doesn't seem so bad. I mean, a few champagne glasses tipped over in first class, but it wasn't that bad. And the crew was wiping their brows, but the guy who built the boat, he's on the bridge and he's looking at the lights. And he says, we got to get everybody off this boat. And they say, what are you talking about? That was close, but it wasn't so bad. He says, no, no, no. We can stay afloat with 4 compartments flooded, not 5. And he can see that 5 compartments are flooding. And the moment that 5th compartment started flooding, that was the threshold. Now, catastrophe didn't ensue immediately. It took a few hours, but he knew that this ship was going to end up on the bottom of the Atlantic. And this is the notion of these twitchy, nonlinear systems. You cross the thresholds, and you put into play feedbacks that amplify the change, and there's just no going back. And it might take a while to play out, but after you're past the threshold, there's no going back. So here's a picture of that, glacial and interglacial cycles that have been playing out over the last several million years. We came out of our last glacial period about 12,000 years ago, at the very back of that, into this other stable little dimple. But again, as you saw, beginning in the 19th century, and most especially starting in the middle of the 20th century, we've moved off into this no man's land, in the middle there. We've gone from what's called the Holocene to what the geologists are now calling the Anthropocene, the age of humans. Humans are now the single largest driver of change on the planet. And the idea is if we don't get ourselves off our current trajectory pretty quick, we're going to cross thresholds. We want to end up back in a Holocene-like state, but at the moment, that's not where we're headed. We're headed to this very, very different climate that is really not at all compatible with an organized global civilization. So in the news now, when we start to hear the reports about the dramatically intensified storms, the fire seasons, the droughts, the heat waves, the coral loss, entire continents on fire, and we start to hear about this as being the new normal, hopefully this graph makes it clear that we are nowhere close to the new normal. We're starting off in this state, and on our current trajectory, we're going to end up in a very different state. And that's going to take a little while. But it's nowhere close to where we are now. So this is a temperature graph, paleoclimate data, temperature data going back nearly 1 million years, 800,000 years on the left, today on the right, showing the glacial, interglacial cycles. You can see the planet mostly likes to be cold. The graph is low most of the time. And then it jumps out of a 120,000 year glacial period for 10 or 15,000 years in an interglacial and then falls back in. So over here on the right, about 10 or 12 degrees Fahrenheit is the global average temperature difference between today and the last ice age. It doesn't look like it on this graph because the time scale is so compressed, but that rise from the ice age to where we are today of 12 degrees Fahrenheit took about 10 or 12,000 years. So roughly speaking, the warming rate is about 1 degree per millennium Fahrenheit. We've warmed 2 degrees in the last century. We're now warming at an order of magnitude faster than coming out of the last glacial period, and we understand why. Here's where modern humans come on the scene. The anthropologists tell us 200,000 or 300,000 years ago, so this is the human climate that you're looking at for our species and our ecosystem, the human ecosystem. And here's where modern human civilization comes on the scene about 10,000 years ago, once we reach this period we call the Holocene, a very stable temperature. And so while we humans are very adaptable, and nobody I am aware of is talking seriously of human extinction anytime soon, we are hugely creative and adaptable. Human civilization, on the other hand, is very finely tuned to the climate we have. Think of all of those cities on coastlines. Those coastlines have been stable for the last 10,000 years. Where we grow our food, how we get our water, how we move ourselves around, etc. So the idea is we need to maintain this state. And that's where statements then like this come from. It's not hyperbole. When people like Anderson, and hundreds of scientists have issued hundreds and hundreds of statements like this, when they make those statements, they're not trying to grab headlines. They're trying to raise a warning. Some people call it alarmist. But the information is alarming. It's not alarmist, it's a warning. So that's the scale of the risk. It's unprecedented. What's the scale of the response then that's required to meet this risk? And the basic physics equation at its core is very simple. More carbon equals more risk. And so what you can do is try to identify what you think is a danger line and say, well, and then calculate a budget. How much more carbon can we dump into the atmosphere and stay below this danger line? And I should be clear, there are already people on this planet in various places who have already experienced catastrophic impacts due to climate change. So it's not like this is something that's going to happen in the future. We're already experiencing it, and for some people it has already been catastrophic. But on a regional scale, as we move, where this danger line is being set is the science trying to estimate where is the global scale, where you start seeing globally catastrophic events. And about 30 years ago, that danger line was set at 2 degrees Celsius of warming, of which we've now warmed a little more than 1. And you calculated a budget about 8 years ago. And that budget was about 1,000 gigatons of carbon dioxide, 1,000 billion tons of carbon dioxide. Now, we've burned through some of that budget since then. That's what it was in 2018. But at the same time, In the last several years, we've discovered that the planet is actually retaining more energy than we thought. It's going into the oceans, and it was kind of hiding there, and it was difficult to measure, but we found it. And as a result, we need to adjust our sense of, well, how much more carbon can we burn? The budget changes because it turns out, oh, we're retaining more than we thought. So the budget decreases by about 25%. Then we also find out that the impacts to both human and natural systems are piling up bigger and faster than we thought. For the amount of temperature change we've seen, we've had bigger impacts. And so you want to readjust, well, recalibrate, what do we think the danger line is? So instead of 2 degrees, 3 or 4 years ago, it was recalibrated and said, you know, we really ought to set it closer to 1.5 degrees. Again, this is beyond which you start to experience global catastrophes, global scale, on a regular basis. For example, the loss of all of Earth's coral. We'll come back to that. So there's our budget as of 2018, January. Here's our budget as of this month, this year. This is for a 2/3 chance of staying below this danger line, and personally, I don't find a 2/3 chance particularly aggressive risk management. That's 2 bullets in a 6-shooter playing Russian roulette. Not one of us is going to pull that trigger. Nevertheless, that's how the studies were set up. So that's a 2/3 chance of staying below that danger line, and here's how fast we're going to burn up that budget. About the next 8 to 10 years. This is very easy to calculate. We understand very well how much we're consuming and at what rates and what our consumption patterns are. So when you hear the press say that we've got 8 years or 10 years or 12 years, or a politician or a scientist, this is where that's coming from. They're not pulling it out of the air. This is where that's coming from. I would simply say that we do need to recalibrate that interpretation. It's a wrong way to state it. We don't have 10 years to fix climate change. We have no time. We have to respond now. The next decade, the next 10 years, is by far the most important any of us will ever live through in addressing this challenge. Here's that budget relative to our already identified carbon reserves. This is coal and oil and natural gas that is currently underground, but we've already found it and we're already digging it up. So this isn't politics. This isn't conservative or progressive or Democratic or Republican. This is just physics. The physics tells us that if we want to engage in any kind of genuine risk management for these extraordinary risks, we can burn less than 10% of those reserves. This is clarifying if you're a fossil fuel community, if you're a fossil fuel company, I think. There's no need to explore for more reserves. We can burn 10% of what we already found. I think it should also be very clarifying for us as a society. We certainly shouldn't be subsidizing the exploration. This has to stay in the ground. This is just physics. Now, if you include non-traditional reserves, the kind that you have to use, like tar sands or fracking special techniques to extract, which we should because we are exploiting those reserves, well then, of course, the reserves are much larger, and really the physics is telling us you can only exploit less than 5% of those reserves. So this is the scale of the challenge that we face. And what does it have to look like? So here's our emissions. This is how much we're throwing up into the atmosphere. Remember, the units are gigatons, billions of tons. Going back to 1990, globally, this is global, we humans emitted about 20 gigatons into the atmosphere. Last year, it was nearly 40 gigatons, and it goes up and up and up and up. Last year, we went up a little, around 2% globally. What we have to do is peak now and start to decline, a managed decline. And that decline, we need to be to zero by the middle of the century or before. And remember, this is emissions. The concentrations in the atmosphere continue to go up as long as those emissions are not zero. So even after we peak, the concentrations in the atmosphere continue to go up. Now, some people call this radical. And precisely, radical just means big or extreme. But we often view the word and use it pejoratively, right? Meaning irrationally big or extreme. This is not what I would call radical in that sense, decarbonization. It is rational. Or maybe the best way to say it, it is rationally radical. Yes, it's extreme, but it needs to be, and it's not for irrational reasons. So we need to decouple our civilization from carbon emissions, and we need to do it very quickly. For the next 10 years, this is what our path looks like through 2030. Currently, on our current trajectory. If all of the countries who are signatories to the Paris Accords, which is all of the countries in the world, except the United States, live up to their commitments, this is what it'll be like by 2030. And this is what we need to meet that graph I just showed you. So clearly, the Paris Accord in itself is not enough, but it was never intended to be. It was intended to be a kick to the rudder to get us moving in the right direction, and then there would be more kicks. But clearly, we're nowhere near close to the response that is required by the risks, by the physics, and according to the risks that we're facing. If you integrate under this curve, for the math nerds in the audience, you get that budget I showed you. And this makes it easy to see that if we delay another year in peaking, peak a little bit later, right now I've got this peak at 2020, this year, if we peak ourselves in, say, 2022, that means we burn up more of that budget up front, and we got to make it up on the back end. If we had started this peak and then decline 30 years ago when we absolutely knew that we needed to do this, it would have been almost trivial. Now, we've undergone 30 years of what one researcher in the field has called predatory delay, which I think is the perfect word. It becomes extraordinarily difficult to do this, and yet now we need to do it. And with each passing year, it becomes considerably more difficult because of what you see here. So what does this need to look like starting now? Let's take a look at that piece of the curve. Roughly speaking, as a rule of thumb, we need to cut our emissions in half globally every decade, starting now, for the next several decades until we get to zero. That is an extraordinarily tall order, no question. What it means is about a 7% per year decline annually, globally, in emissions. We've never come close to that. We've only gone up. The only time we had a blip going down was during the big financial crisis of 2008, 2009, and a few years after that. So this is absolutely huge, but there's yet one more little piece to this puzzle that is very important. Not everybody on the planet is equally responsible for the pickle that we're in. Turns out that about 10% of the people in the world are responsible for about 50% of our material consumption, 50% of our carbon emissions. So there's a lot to be gained here at the very top end of consumption. If the top 10% of the world's emitters, those people with the very highest carbon emissions, were to cut their emissions to just the average emissions of the average European citizen, that would cut our global emissions by 30%. That's how much the very top emitters are consuming. 20% of our material consumption and carbon emissions come from, 80% of our consumption and carbon emissions come from just 20% of the population. That includes all of us in this room. It is so skewed toward the wealthy nations that if the top 1% of the emitters in the United States, that's about 3.5 million people, I want to compare the emissions of the top 1% in the United States, about 3.5 million people, to the emissions of the bottom 1% of the world, about 75 million people. And it turns out that the top 1% of the United States, which is about 1/20th of the number over there, consume 2,500 times as much as those people over there, and emit 2,500 times as much carbon. In other words, it would take 188 billion of these people to equal the current emissions of these people. That's 20 times the population of the planet. And so, clearly, the responsibility for meeting these emissions drop, the drop in emissions, these goals, should not be equally distributed among the people, all people on the planet. Not everyone's equally responsible, and also not everyone has the same capacity. In Bangladesh and Myanmar, they're just trying to keep the lights on. Should we ask them to reduce their carbon emissions this year 7%? No. I don't think by any reasonable moral sense would that be true. And so when we look at this graph then, even though globally we need to reduce our emissions 7% annually, what that really means is for the developed nations, it needs to be more like 15% annually. There's no question this is just an enormous task. It's not clear that we can do that. It's just not clear. That's the bad news. The good news is we haven't even tried. Not at all. And I do not mean to diminish the efforts of so many people who are working on these issues. I'm not trying to say that people have not been working on these issues. Many, many people have. And those efforts are starting to overlap and amplify each other. This effort to address this is also nonlinear. There are tipping points in our effort to respond beyond which we can start to gain ground very big. This is almost certain. But at the moment, we're not even close. Most of our society isn't working on this at all. So, from the climate standpoint, the scale of the risk, the scale of the response that is required is this. We need to bend the emissions curve now. We need to cut our emissions in half every decade globally, and that means for us in this room, 15% annual declines, and this is applicable at any scale, from the home to the community, to the state, to the nation. So if you're taking this in, you're probably saying, what can I do? Many of you have probably already thought about that and are already trying to do things. And I want to make just a few comments about that. We tend to try to take these things on ourselves, and there is a concerted effort among various interests in our society to try to put this onus on us as individuals. I think it's very important that we, as individuals, accept some of this onus. Psychologists call it taking ownership of the problem. And for the first few years in this decade, this isn't too hard. I think everyone in this room can probably cut their emissions footprint this year 15% over what it was last year without too much trouble. Can you drive 15% fewer miles? Can you fly 15% fewer miles? Can you eat 15% less industrial animal agricultural products? Industrial animal agriculture is a huge piece of our emissions puzzle. It's 80% of agricultural emissions, and agriculture is about a third of our total emissions. So how we eat definitely has an impact. How we move ourselves around definitely has an impact. And you can do that for a year or two. But the problem right now is that the systems that we're embedded in fight us. And as we reduce our emissions further, they fight us more. It becomes harder and harder. What we need is for those systems to help us. So we can reduce our personal footprints 15% a year for a few years and maybe give the systemic changes a time to kick in, but they've got to kick in quick. If you were to take that carbon budget I showed you earlier and distribute it equally among the entire world's population, give everybody a carbon ration, a lifetime carbon ration, everybody gets 44 tons. 44 tons is our lifetime carbon ration. In my home state of Utah, and I think the footprint here in Colorado is quite similar, each person emits about 19 tons a year. So we're going to burn through our global ration, each of us in this room, in 2.5 years or less. If you were to go home, turn out all the lights, eat nothing but kale, never go anywhere, and decompose on some garden seeds, your footprint in this state would still be over 6 tons a year. You're embedded in systems. So you would burn through if you lived like an ascetic, instead of burning through your lifetime carbon ration in the next 2.5 years, you would burn through it in the next 6 years. Personal response is not going to take us where we need to go, not even close. These problems are arising from the systems that we are embedded in. The systems themselves have to change. They don't need to be reformed. They need to be transformed. This isn't about changing out components. This is about completely rethinking how we do it. And the good news is, we know how to do it. To the extent that this is a technological problem, we have the technology and the knowledge to do this. We have it. Now, we'll get more and better technology, and that'll help, but we don't need it. This is primarily a cultural problem at this point, getting ourselves to do it. Okay, so that's climate. And you get a sense of the scale of the response that's required. Now I want to put this response into a broader context of how humans have been impacting our life support system, the Earth system. Sorry about that. I don't want you to look at the details. You don't have to read anything. Just look at the shapes of those graphs. You see that dramatic growth on the right-hand side. This is human impact on the Earth system, our life support system. Dramatically, fundamentally changing atmospheric chemistry, and starting in the middle of the 20th century is where everything takes off. Dramatic exponential growth in concentrations of greenhouse gases, in depletion of stratospheric ozone, which thank goodness we got a hold of in the 1980s by accident. Surface temperatures going up, basic changes to ocean chemistry, massive extraction from the Earth system. This is marine fish capture. Nitrogen to coastal zones. This is from fertilizer that we put on our fields that then washes into the rivers and washes down to the oceans and creates massive dead zones in the oceans, depleting them of oxygen. The marine life swims in and dies because there's no oxygen. But again, look at the shapes. Tropical forest and land impacts. This is what's been happening in the natural system. The documentation to this is extreme. The Intergovernmental Panel on Climate Change, the Intergovernmental Panel on Biodiversity and Ecosystem Services, the National Climate Assessment, the WWF Living Planet reports, the Global Footprint Network, all of these organizations synthesize thousands and thousands of scientific studies with an eye towards what are we doing to the biosphere, the living bits on the planet. And this is what we're doing. In the last 4 decades, we've wiped out 60% of the world's living creatures. The extinction rate, the ecologists tell us, is now between a factor of 100 and 1,000 times elevated above the background extinction rate. We're tossing species overboard at a phenomenal rate. At this rate, by the middle of the century, 1 million species may be at risk. And this, by the way, is not due to climate change. They tell us that climate change is responsible for something like 10 or 15% of this impact at the moment. As climate change intensifies, of course, that impact will grow. But this is fixed climate change tomorrow. This is the same. This is due to massive extraction and massive pollution of the environment, something we've become extremely efficient at through destroying habitat. Seabirds are down 70%. Elephants, 70%. Lions, 90%. Large fish, 90%. Sharks are down 95%. All since the middle of the 20th century. If we continue on our current path with climate change and past that 1.5 degree mark, the marine biologists tell us we risk losing all of the world's coral reefs. We've lost 1/5 of them, something like 20% of them so far. The coral reefs are the tropical rainforests of the oceans. They're habitat to enormous numbers of species. They're a critical piece of the marine ecosystem. Completely gone by 2040 on our current trajectory. Insects across Europe in the last 3 decades, 3/4 gone. In Puerto Rico, more than 90% of the insect biomass gone in the last 4 decades. The evidence to this is extreme. This is scientific knowledge. Why? Okay, if that was the Earth system trends, think of this as people system trends. Look at the shape of the curves. Since the middle of the 20th century, dramatic rises in population. GDP, think of that as a proxy for material and energy use, throughput of the system, and pollution. Foreign direct investment, think of that as a proxy for globalization. This is not just regional anymore, these impacts, they're global. Energy use, urban population skyrocketing, fertilizer consumption, which wreaks havoc in the biosphere, particularly phosphorus and nitrogen. We've dammed just about every river in the world, which wreaks havoc with the ecosystems in those rivers and social systems that used to live there. Our use of blue water, paper production, think of this as a proxy for impacts on forests. Transportation, of course, telecommunications, international tourism, again, another proxy for globalization. We can see that the human impact, the human systems are dramatically increasing their impact. This is where the impact on the biosphere is coming from, on the planetary system. Taken all together, the scientists who study this refer to this period, starting in the middle of the 20th century, as the Great Acceleration. And it's important to understand this for the following reason, because sitting here in this room, it just doesn't feel like we're on the hairy edge. I mean, I think you're taking in what I'm saying intellectually. But you're going to walk out of this room into your lives, and most of us in this room have pretty nice lives. And I don't want to diminish problems that we go through. Some can be quite intense. You know what I mean. But most of us go home in nice cars, to nice homes, and nice food, in a nice, safe, secure community. I'm telling you we're on the hairy edge, and it's not me, and the science is telling us this. Our collective knowledge is telling us this. But it just doesn't feel like it. We have to internalize the fact that this is true. It doesn't feel like it because of this phenomenon of exponential growth. Oftentimes the critique is made, the ecologists, they're always telling us the world is coming to an end, it never happens, The problem is, we are in a fundamentally different place, a place humanity has never been in. It used to be okay to say that when we were what's often referred to as a small world on an empty planet, meaning the human metabolism on the planet, the human throughput of material and excretion of waste was small compared to the planetary systems. But that is no longer true. We are no longer a small world on an empty planet. We're a big world on a full planet, meaning the human throughput of material and excretion of waste is now as large as the planetary systems themselves. So this can't continue. And it leads to statements like this in the scientific literature. Planetary scale critical transitions, rapidly, unpredictably, irreversibly. If you're thinking to yourself, that doesn't sound good, I think you're properly understanding the message. Which has led, as I mentioned earlier, the geologists to rechristen our current geologic epoch the Anthropocene. Humans are now the single largest driver of change on the planet. And growth is what's driving it. Let's just take a minute to understand this notion of exponential growth. See that little black set of pixels there that I've colored in? If I were to add another pixel that size every second, it would take us 10.5 hours to fill up this screen. I've done the math. That's called arithmetic growth, and that is not how we were growing. Now we're undergoing exponential growth, and exponential growth means you grow by a certain fraction in some period. So X% per year. So let's just say that I'm going to grow this so that I double it every second. I double that square every second. Let's see how long it takes to fill up the screen. We're in the upper left up there. Ready? Go. 2, 3, 4, 5. "15 seconds. This is the power of exponential growth. And now imagine that this screen represents the whole of our planet, our planetary resources available to us. At what point in that 15 seconds Did we look out over our resources and say, we've got half of them left? At what point did that happen?
14.
At 14 seconds. And then just one more second and it was all gone. Now, if you grow something at 3.5% per year, it will double every 20 years, just a tad more. If you grow something at 3.5% per year, it will double every 20 years. That's roughly what we've been trying to do with our global throughput since the Industrial Revolution. At 3.5% per year, instead of a second, we doubled every 20 years, it took 300 years to consume that first half of the planet. And then how many years to consume the other half? One more doubling period, 20 years. Now, this is what physicists are screaming, and environmentalists, and have been pointing at this since the 1970s or so. This is where we're headed, and now we're there. Now, in the world of economics, your average economist, even the progressive ones, will tell you this is not a problem. And they use one word to tell us why this is not a problem. Anybody know what the word is?
Technology.
Yes, except there's a broader word, innovation. We will innovate our way through this. The Stone Age, they tell us, did not end because we ran out of stones, right? And again, when we were a small world on an empty planet, that argument had some merit. But that's no longer true. We're bumping up actual geophysical limits. And that argument no longer holds. But let's suppose for a moment that it did. Let's suppose that through our innovation, we somehow innovated our way to 3 more planets worth of resources tomorrow. Whoa. There they are. 3.5% growth per year, which is what the economists tell us we've got to have to thrive. How long to consume the next planet? 20 years. How long to consume the next 2 planets, because we've already consumed 2? 20 years. Our unimaginable fairy tale innovation that found us 3 more planets worth of resources bought us 40 more years. It doesn't work. In 2016, we were consuming something in the order of 160% of what the planet could supply sustainably. We needed 1.6 planets to continue our consumption just as it is, and excretion. Modified to 1.7 planets in 2018. Now, again, the economists tell us, who are meeting in Davos right now, that we've got to grow at 3.5% every year. That's development. We've got to do that. That's how we lift everybody out of poverty. That's another story. So our plan on purpose, by some highly educated Ivy League people, is to tell us that our plan on purpose is to be overconsuming our resource space by 300% in the next 20 years and 600% in the next 40 years. What physics is very clear about, the physics of complex systems, is that the chances that we reach anything like that level of overshoot of our resource base are essentially 0. This is without climate change. Fix climate change tomorrow, that changes nothing about this picture. In fact, the systems that have created this culture of hyperconsumption are the same systems that are driving climate change. But if you think about climate change and we say, well, the problem is we've got to produce carbon-free energy. True, we do need to do that. But if we change nothing else, what do we do with that carbon-free energy? Same thing we did with the high-carbon energy. Hyper-extract, hyper-consume, hyper-excrete. So fix climate change tomorrow, the systems that we are currently embedded in, that we must transform, will be gone in the next 2 to 4 decades, probably closer to 2. I mean, particularly from a risk management standpoint, you don't want to just push it right up to the edge, right? We're running up against hard physical boundaries. If everyone in the world today hyper-consumed, the way that we Americans hyper-consume, because we are practically forced to, from cradle to grave, by the systems we're embedded in, if everyone on the planet consumed the way we in this room consume, it would take between 4 and 5 planets to sustain us. That's today. And of course, all of those numbers, 1.7, 3, 6, 5, the most salient feature about all those numbers, right, is they're bigger than 1. So the task before us is not to continue on our current path or transform these systems. These systems are going away. Our task before us is to make it soft landing, not hard. These systems are going away, and we can put a cap on it, probably less than 4 decades from now. Probably much less than 4 decades from now. In fact, we must assume that from a risk management standpoint. So we got through the climate problem, and that was pretty intense. I mean, the portion of tonight. And then I showed you this. Why did I do that? Am I purposely trying to drive you into despair? Remember, some of us need more planets than others. Not everyone in this world is equally responsible for that situation that I just showed you. And not everyone has the same capacity to fix it. And those of us in this room are the ones that are embedded in the systems and in the nation that has tremendous wealth and does have the capacity to transform this. And the reason I show you this and how it's relevant to the climate fight is because when you start to put the response to climate change into this much broader context, a whole lot of more doors open up in terms of avenues for response. There's this quote from Dwight Eisenhower, which I think is appropriate. And what it means is, if you're not finding a pathway to solve your problem, you're probably not including enough pieces of the problem. So that brings us to, now, can we meet these challenges? Climate change, certainly the most acute, but forget climate change. We live in a completely unsustainable state. Unsustainable in our lifetimes. It's not clear that we can meet this challenge. And it is very easy because the steady stream of bad news hits us every single day, especially if you're paying attention to these issues. Now, I haven't given you any more bad news today. What I've done is synthesize all the bad news you've already seen and put it into a tight package. This is what we know. This is where we are. And so oftentimes people say, well, is there hope? Is there any hope? And we are tempted to go into despair, and trust me, I understand that. We all have our days. And so what we've got to do is find a mindset from which we can move forward with the response that is required of us. And the mindset involves understanding the response that is required of us, in my opinion. So the first piece of this mindset is that even though we don't know if we can do it, we certainly don't know definitively that we can't. And absent conclusive evidence that says the asteroid is coming and there's no deflecting it, our job is to take the next step. That is our job. We don't have to see every step to the top of the mountain. Our job is to take the next step. And it becomes easier if we put ourselves in a mindset of emergency. Putting yourself in the mindset of an emergency completely changes the framing. In the mindset of an emergency, the hope-despair framing is completely inappropriate. In an emergency, you don't hope that you get out. You just get out. If the house is on fire, you don't hope you get out. You just get out, or you die trying. But you don't sit down in despair, and you don't sit down and say, well, I hope I can get out. We just do it. That's the wrong framing. The reframing is resolve. And you get that if you're in the mindset of an emergency. In fact, you get a number of different mind spaces if you're in the mindset of an emergency. So let me talk about just these three. I want to wrap up with these. First, this notion of radical versus rational. So given what you've already seen, and with this sort of colloquial definition of radical as irrational, as bad, let's first define what is not radical. Knowing about a crisis and responding is not radical. People and institutions that know and respond are not radical. What is radical? Knowing and not responding. And so that puts all of you in this room tonight in a pretty uncomfortable space. Because I would argue that the problem in the climate crisis at the moment is not those who will not look at what's happening. It's not the obstinate, it's not the deniers. The problem is those who get that we have these problems and still refuse to respond appropriately. I often get accused of preaching to the choir. I suspect most of you in this room came tonight because you're interested in these topics and you get that we have these challenges. That kind of makes you the choir, if you fit that description. There's a great quote, I don't know who did it. I even tried to find out, but I couldn't, even with the Google. Why do you preach to the choir? Does anybody know? To get them to sing. We got to sing. And if you're not singing at this point and you understand where we're at, that is radical. This is radical. 99% of the material mass sitting on store shelves right now will be in landfills in 6 months. I'm not making that up. 99% of the material mass sitting on store shelves in the United States right now will be in landfills in 6 months. This is radical. We don't need further exploration. We got to shut it down. We have to. What's in the ground right now has got to stay in the ground. If it gets extracted, it will get used. If it gets extracted, it will get burned. It's got to stay in the ground. Intense, massive, global industrial pollution is radical. This is certainly radical. This is radical. Not radical. Knowing, calling it what it is, and responding is not radical. Most of you know this, many of you know this young woman, Greta Thunberg. I think she just turned 17. She was 15 when this picture was taken. She became absolutely despondent, Swedish teenager, because none of the adults in her life were responding to what she was learning in school in a manner that seemed to her appropriate. And she was absolutely right. She said, what good is school? She sat herself down in front of the Swedish parliament with this sign that says, school strike for the climate. Just in desperation. A year later, she's headlining rallies of 40, 50,000 people across Europe, students who are school striking for the climate on Fridays. Last October, she was kind of the face of a global 7 million person strike and school walkout. And whatever this is, it is not radical. This is a rational response to the situation we are in. Okay, the other thing that a mindset of emergency does for us is to clarify this discussion on viable. Fine, I said, clearly it's taking transformative action, and you're all sitting there going, everything I can think of that's transformative is not viable. It may be technologically or politically. And so I'm telling you, everything we need to do technologically is viable. We can do it. It's a cultural problem at this point. It's a political problem at this point. So let me point this out, though. Suppose I said to you, okay, what we need to do tomorrow is outlaw the manufacture and sale of new automobiles. Anybody in this room think that this is politically viable? We did it. We did this. December 1941. Congress passed a law, the president signed it, banning the manufacture and sale of new automobiles in the United States for the foreseeable future. Ford and GM, you're going to make tanks, you're going to make airplanes, artillery, trucks, everything we need to meet this emergency that we are in of World War II. Everything in the country was rationed. People planted victory gardens, they bought war bonds. Millions of young men signed up to go into the military. Many young women signed up to go work in the factories. Many of them served in the military. But we did that. What was inconceivable in September of 1941 was done by the end of December. And it was done because the groundwork had been laid ahead of time. FDR, his cabinet, many industrialists in the country at the time saw what was coming. And they had these agreements, they had these roadmaps, and that's the good news. We have roadmaps to do everything we need to do. We know how to transform how we do our food. We know how to transform how we do our energy. That's the easiest one. We know how to transform how we do our economy. We do not have to have a growth-based economic system. And we know how to do economic systems that are not that. We've got the roadmaps ready to go. So, from a standpoint of an emergency, our North Star needs to be not what's viable, but what is necessary. That's the goal, what is necessary. And then making it politically viable is just another step. But we keep our eye on what is necessary. So, ground all flights, tell everyone who is on them to find their own way home and never fly again. We did it. September 11th, 2001. So things like walkable cities, mass transit, high-speed rail, fully distributed power systems, all those things are technologically possible right now. Keep it in the ground. That's the easiest one to do technologically. Culturally, of course, this is a really huge subject. I'm just saying that an emergency mindset changes the things that you think of as viable and not viable, that we think of as viable and not viable. And finally, I want to talk of this notion of hope and despair and achievement. I think most of you recognize this guy, Winston Churchill, who was a really complicated guy. But with the emergency of World War II, I think is particularly prescient. So in the spring of 1940, he had just become prime minister. Britain was on the verge of surrendering to Nazi Germany. The British expeditionary forces in Europe, 300 and some thousand soldiers, were trapped at Dunkirk. The previous prime minister, Neville Chamberlain, and his government had just resigned. They had been in talks through Italy with Hitler to surrender, and for the previous 4 years had been saying that Hitler was no problem. Of course, in 1936, Churchill gave the famous speech where he said the time of expeditious such and such is over. We have entered a period of consequences. That was in 1936. 4 years later, no one had listened to him in the government. Now he's prime minister with a mess on his hands. He can't get his troops out. And people in his own government are talking about surrender. And he goes on the radio and he gives this very famous speech, right? We shall fight them on the beaches. And we shall fight them in the cities, and we shall fight them on the hills and on the landing grounds, and we shall never surrender. We shall never surrender. We shall never surrender. And it's extraordinary. The position he was speaking from was utterly hopeless. Utterly hopeless. They were going to be under Nazi rule in a matter of months. But his mindset clearly was not of hope or despair. His mindset was resolve. You hear that in the words. You resolve to do something, and then you figure out how to do it. And you never, when it's really hard, there's nothing we as a society ever figure out that's really hard and takes a lot of effort until we're forced to do it, and we figure it out, right? So I want to play the risk of beating a dead horse. One more example in history. Of course, Chamberlain figured it out. Churchill figured it out. It wasn't the Navy that rescued the troops at Dunkirk. He put out a call. He said, every possible civilian craft that can go across the channel and pick up our troops, do it. 330,000 troops were rescued in the course of like 10 days or something like that, right? You have to commit to what you're going to do, and then you figure it out. Apollo 13 is another quick example I like to use. So most of you know the story, but for those of you who don't, haven't seen the movie, Apollo 13 launches. It's on the way to the moon. We're 1970. Partway to the moon, there's an explosion. There's two spacecraft here, right? There's the LEM, that's the Lunar Expedition Module. That's what's going to land on the moon. And there's a command module. That's what orbits the moon. And then the astronauts come up from the moon. They move back into the command module, and that's what takes them back to Earth. These two are linked. They're on their way to the moon. There's an explosion. And all hell is breaking loose in the capsule. They're losing oxygen. All kinds of things are going wrong with the spaceship. It looks like these guys are kind of doomed. It's a bad situation. And now we're at NASA. This is mission control, and the engineers are trying to figure it out. And we all understand that this is 1970, and all the aerospace engineers were white men. That's what you're going to see. Okay.
So you're telling me you can only give our guys 45 hours? That brings them to about there.
From the moon back to the Earth.
Gentlemen, that's not acceptable.
We gotta talk about power here. Whoa, guys! Power is everything. Power is everything.
What do you mean?
Without it, they don't talk to us, they don't correct their trajectory, they don't turn the heat shield around. We gotta turn everything off. Now. They're not gonna make it to re-entry.
What do you mean, everything?
With everything on, the LEM draws 60 amps. At that rate, in 16 hours, the batteries are dead, not 45. And so's the crew. We gotta get them down to 12 amps. 12 amps? How many? You can't run a vacuum cleaner on 12 amps, John. We gotta turn off. We have to turn off the radars, cabin heater, instrument displays, the guidance computer, the whole smack.
Whoa, guidance computer. What if they need to do another burn? Gene, they won't even know which way they're pointed.
The more time we talk down here, the more juice they waste up there. I've been looking at the data for the past hour.
That's the deal?
That's the deal.
That's the deal.
Okay, John. Minute we finish the burn, we'll power down the LEM.
All right.
Now, in the meantime, we're gonna have a frozen command module up there. In a couple days, we're gonna have to power it up using nothing but the re-entry batteries.
We've been tried before. Hell, we've never even simulated it before, Gene.
Well, we're gonna have to figure it out.
Oh, we're going to have to figure it out. We're not even close to meeting these challenges. That's the bad news. The good news is we haven't even tried. We're going to have to figure it out. And we can. I believe that. You talk to people who climb mountains, and it's hard and it's painful. In fact, really unpleasant. And they never talk about it that way. They talk about it like achievement. From the right mindset, we have extraordinary opportunity in front of us to transform everything, and it needs to be transformed anyway. This is something that we can do with our lives. And whoever you are, and whatever your talents and whatever your means, there is work for you in this. If you are or want to be a lawyer or an architect or a chef or a farmer or a rancher or a scientist or a politician or a lawyer or a banker or a financier or an artist, there is work for you in this. More than anything, I think we need the artists. Because as good a science lecture as I give, and I give a damn good science lecture, it wasn't Berkeley sociologists that were connecting us to the changes of the 1960s. It was 19-year-old musicians and writers and poets and filmmakers. We as a society need to connect to this message from our socks. In the 1850s, Harriet Beecher Stowe wrote a book called Uncle Tom's Cabin. American historians often point to this book as a watershed moment in the discussion on slavery in this country. It's not like the preachers hadn't been pounding the pulpits for decades talking about how evil slavery was, and it's not like they were wrong, but the country was at an impasse. And then Harriet Beecher Stowe wrote a book. She wasn't a preacher. She just wrote a book that was a story about a family. And it resonated so deeply with so many people. Historians now consider it a turning point in the pathway away from slavery. We need to be telling these stories in our society in ways that are connecting us to them. We all need to be talking about it. We all need to be telling this story to our friends, our family, our peers, our faith leaders, our political leaders, everybody. We don't have to do everything, but we have to do something. And there is work for all of us in this. So you need to figure out what that is for yourself, and there are people here tonight that will help you figure out what that is for you and let you know what's going on in your own community. We want hope, and we don't want to be in despair, but hope isn't free. If you want hope, act. That's the way it's going to work. In the meantime, what we need is resolve. We see a next step, and we take it, and it's got to take us out of our comfort zone. And we also need to, I'm going to make one more comment, and that is, this isn't about finger pointing, like you drive an SUV and you fly 15 times a year and you keep eating steak and hamburgers. It's not that. We all have different capacities and we all have different abilities, even at different times in our lives. So let's give each other the respect of saying that they're doing what they can, and let's just pay attention to what we're doing. And what we're doing has to be plugging ourselves into efforts that change whole systems, and we got to do it now. That's our opportunity, and it is enormous. Thanks, everybody, for your attention.
Again, thank you all for coming to hear Rob speak. We're going to get our panel set up really quickly here that Rob will be a part of as well. So we'll get into more local focus outside of this global one. I want to mention to you, too, Rob spoke in Steamboat last night, and Commissioner Chandler Henry was talking to one of the Routt County commissioners, and he just said, "I'm depressed," which is one of the ways you can come out of this. I mentioned to you before at the end of his talk in Park City, we were energized, and I think it was that. And maybe it's just, maybe I'm a simple person. But I find, too, that usually the more choices I have in life, the unhappier I get. In this case, this comes down to just simple choice. We're about to talk about our climate action plan as part of this conversation, too, that we have in this community. And I was part of the large group that decided on our goals. And the way I remember that conversation in that room at Walking Mountain Science Center was we had kind of 3 sets of master carbon goals with subsets of each industry kind of thing underneath. And it was sort of like a wine list. It was like, all right, here's the really aggressive, this is where the science says we need to be, and we have no idea how we would get here. And then, of course, there's the one down here like, oh, that's easy. Like, you're not going to choose that when you look bad on a date. The middle one, of course, is it's aggressive, but we can see how we'd get there. That was viable. We figured that was viable and aggressive. We knew when we made that decision that it was not what the science said is necessary. So if we've all seen this presentation, you put us back there, what was that, 3 or 4 years ago when we did that? I want to see the person who's going to choose the middle path. So to me, this makes it all just very straightforward. If we talk about all sorts of different solutions, but only one of them is the one that works, I'm happy. I have no idea how we're going to get there, but that's our choice, and it makes life really easy, and then you just go out and you do it, as Rob was talking about. So we're going to bring up this panel, too, and that question, remember, that we were left with is, what now? So I will bury the lead here and tell you, I don't have the answer for that question. Rob didn't have it either. That is the question that is, as I mentioned to you, we tried to fill this room with as many community leaders as we could, philanthropists, elected officials, and business leaders, education leaders. And it is going to be up to all of us, if you have seen this, to then figure that out. What is it that we do? So the challenge with that is there are so many hurdles to it, and at the local level, it's very difficult to consider. So what we're going to do is have a little conversation with some people who are local to us, along with Rob, to try and get us at least to a place to understanding some of that. So is everybody ready here? Excellent. Rob, you can come up too. Rob needs no further introduction. We have a stage full of doctors. I feel this is kind of a weird psychology session. Here, Rob, you step one over. Well, actually, that's fine. You can do that. That'll work. Okay, so, you know, this is a relatively small community. Many of you know the people on the stage, but I do want to give sort of the credentials and bios here because it's important. Dr. Kim Langmaid is now the Mayor Pro Tem, congratulations, of the Vail Town Council. She's also the founder of Walking Mountain Science Center, which we all know. And she's Associate Professor of Sustainability Studies at Colorado Mountain College here in Edwards. And it's important to note that Kim co-facilitated the creation of the Climate Action Plan for our community, and she serves on the Education and Outreach Working Group of the Climate Action Collaborative. Then there's Dr. Brian Hannigan, who many of you know too. He's the president and CEO of our local energy cooperative for most of our community. Some of us have Excel to the east. But he's the president and CEO of Holy Cross Energy. And here's some of the important parts of Brian's extensive bio that I'm going to pull out. So prior to joining Holy Cross in July of 2017, Brian was an associate laboratory director at the National Renewable Energy Laboratory in Golden, where he co-founded the U.S. Department of Energy's Grid Modernization Initiative and started up the Energy Systems Integration Facility, a unique distribution grid in a box, enabling utilities, entrepreneurs, and consumers to work together on cleaner, more affordable, and more reliable energy systems. Brian's PhD is in Earth Systems Science. So, in addition to being CEO of an electric co-op, he's also a climate scientist. So, that's all of our CVs here, too. So, I want to start this question off coming to Rob as well to get us down from that global piece into more of our local. I'm here. You talked about the individuals. What I think we have globally been saying is the opportunity and responsibility of the individual to act. We also have, I think in local communities here and in a lot of other places, amped that up a bit to where we green our operations. So Eagle County has done it, the Water District has done it here. Lots of towns on their own have gone 100% renewable and done a number of things with our own operations, thinking, well, that's kind of the first step. But we have done that, and again, bearing the lead, when we look at our climate action plan, when we take out the advances Holy Cross has had with its renewable generation on the grid, we have effectively made zero progress on our climate goals, on our climate action plan. So we're well behind where we need to be locally on our climate action plan. So can you speak to what is necessary that we have not yet begun to address? And you did that a bit here, but from a local perspective, what does that look like, particularly system?
You know, I think at the conference we were at, the Mountain Towns Conference, Paul Hawken was there, and Paul Hawken, for those of you who don't know him, has a long history as an environmentalist, a very effective ambassador for this, and has this project Drawdown, which is a collaborative of a lot of scientists that created this book called Project Drawdown. It's a great website that identified the 100 biggest activities for sort of the lowest hanging fruit for decarbonizing our global civilization. And at the top of that list was refrigeration, for example, globally, just chewing up huge amounts of energy, and there's a lot of room to improve that, apparently with refrigeration. They crank through the numbers. I suspect that's not the biggest thing that Eagle County can do, although I'm staying in a lovely hotel down the road here that's got, I don't know, 1 million rooms. Each one has a full-size refrigerator, and all of them, I'm pretty sure, are empty. So that said, I think having your own local drawdown initiative where you're going to identify, and like you said, here's the biggest things that we can do. You just said that you've tried to do that to some level. You find yourself a few years down the road and you've made no progress. I don't think that's necessarily, that's data. You know what doesn't work. And so now you know that you have to amp up the game. Certainly leadership is going to be hugely important. And you mentioned that everybody in this room is a leader. I think by the very fact that you're here, you're going to turn yourselves into leaders. At the local level, it requires people who can speak to different communities, so to speak. The business community, the academic, the agricultural, et cetera. And help people see that a much larger scale is effort. So I certainly don't have the answers. I certainly do know now that leadership at the community level is now important. This requires risk-taking among councils and mayors. And I understand that there's a navigation, a calculation that has to happen. But I don't see any way now that we navigate this without really strong leadership in all positions. That's the best I have to offer you.
And that's exactly the message I'd like to hear, too. So thank you, Rob. And Brian, speaking of transforming systems, there is not one probably more apparent and understandable and important to all of us than the electric grid. In light of Holy Cross's recent accomplishments in greening its grid and meeting substantial goals, what will still be needed for a carbon-free infrastructure, and importantly, what can our community do to accelerate and achieve that?
Great. Thanks, Matt. That's a question we grapple with every day at Holy Cross. And I just want to thank Rob for putting it simply, because you can take all this complex climate science, hundreds, if not thousands of scientists and sociologists and engineers doing work around the world, and there's so much complexity, sometimes it's overwhelming. But if you take nothing more away tonight, I hope you take more carbon equals more risk. Because to me, it's all about the carbon. Both in my studies as a science guy and then ultimately focusing on energy systems and to some extent focusing on the grid, because you want to reduce the carbon, you go where the carbon is. And our energy system is inherently carbon-based. In fact, close to 80% of the carbon that we emit globally comes from the production, the delivery, or the consumption of energy. And so one of the things that we did in September 2018, and several of the board members are here tonight, but it was with the help and encouragement of this community, and I'll come back to that in a moment, is we took on a pretty ambitious goal. We said, September 2018, we said, by 2030, let's make the move to, and we did the homework and did the calculation and realized we had a pretty clear path on how to get there. Let's get to 70% clean energy on our utility system, and along the way, reduce our emissions from our power supply, not our whole business, but our power supply. Let's reduce that by 70%. And well, we've done the homework, and we think we can actually get there without increasing the cost of that power supply beyond what it would be if we did nothing. And I'm proud to say that in the last 18 months, the rest of the utilities in the state of Colorado have joined us. Most recently, the Large Generation and Transmission Cooperative. They also brought their goal forward to the point now where every citizen in the state of Colorado, no matter who they get their electricity from, in the year 2030, may not be quick enough, but that electricity will at least be 1/2 from clean and renewable resources, something that frankly was unthinkable statewide 18 months ago. Now, Rob's numbers will tell you that's a small drop in the bucket. We at Holy Cross, we are 1 million tons of carbon. We are not 40 billion. But our thesis is, look, if we can demonstrate the art of the possible, if we can figure out how to make it happen at a 1 million ton scale, then maybe somebody much bigger than us with more people to serve, more resources to bring to it, will 10x it. And 10x it again, and 10x it again. And as you saw in his presentation, if we can get that exponential growth in the solution, then we might be able to match the exponential size of the challenge. So in my 20 years of working on energy technology, from political to technology to now practitioner, the Project Drawdown and all of the other projects like it, when it comes to the energy sector, it boils down to 4 key things. The first is you employ every single measure of energy efficiency you can find possible to deliver the services using less of the resources. And by the way, that's good not just for energy, but for every other asymptotic curve that Rob showed. And that's a mindset to get into. We've been counter to what a utility should be doing economically, trying to sell more and more electrons every year. We've been voluntarily seeking to achieve 0.5% per year in reduction in our sales through energy efficiency. The natural normal growth here is not 3.5%, it's less than 0.5%. So we're actually trying to reduce the amount of money we as a business have every year. It's a different problem. That's economic sustainability, right? But it's an unnatural act that actually makes more sense for the environment when we think about it from the long haul. Lighting retrofits, heating and cooling, tighter building envelopes, a lot of the things that you saw in there in the lobby this morning. But that's step one. That only takes the problem from here and brings it down to here. The second step is our 70-70-30 plan, transform our electricity supply into clean electricity. Why? Well, that gets at 1/3 of the energy problem from an emission standpoint, but it makes steps 3 and 4 even easier to do, and that is step 3, push that clean electricity now into the transport sector, into the building sector, into commercial, industrial, agriculture, because you've now given those sectors this great new tool, this clean, affordable fuel called electricity that they can use to help keep the other stuff in the ground. And we're already beginning to see that with transit buses, thank you, ECO. We're beginning to see that with the 130 plus folks that have gotten free level 2 chargers from Holy Cross and gotten them installed with our help to charge their electric vehicle that's no longer running on petroleum. We're seeing that in air source heat pumps and other approaches to clean heating, which I think for this area, given our energy demand, clean heat, not clean air conditioning, as in some other parts like California, that's going to be our next big challenge, and one that if you're an entrepreneur, I encourage you to put your mind to. Lots of potential opportunities there to look at our codes and our standards, look at our initiatives, where we put our money and where you as consumers put your demand. And then the last thing I'll say is there are parts of the economy that right now really need a dense, heavy, liquid fuel for which electricity doesn't work. We need to figure out how to make that low carbon. We need to take the extra wind and the extra sun that right now is a problem for the electric grid, turn that into a fuel that can be used for long-haul jet travel. Because as much as we might want to ban jet travel, it would be a lot easier if we could figure out how to do that in a carbon-free way. And then set about solving the other problems that still remain, as Rob described in his conversation. So, you know, and there are lots of other things we can do. We can start pulling carbon dioxide out of the atmosphere and trying to transform that into a fuel. We can start looking at our forestry and our agriculture and so on. Right now, what we can do as members of Holy Cross, as the electricity provider in this community, is that we can set to our problem, our part of that challenge, and really focus on the electricity supply, and then call on the other segments of society, you all, your elected leaders, your towns, your communities, your businesses, to jump off of that, to take this clean fuel and now go do something with it at a pace and a scale that matters. And that's really what it's all about. And if we can tonight come up with a few ideas for perhaps a step change, can we envision how a tourist comes to our fair town and lands in a carbon-free airplane at a net zero airport, takes a completely renewable driven electric rail train the length of the valley from the Eagle Airport to the ski resorts, stays in a carbon-free hotel and participates in a wonderful sport and an economic value to us, free of a carbon footprint. If we can see how to do that life cycle, that's probably no more difficult than bringing the astronauts home, right? But if we can start to think about that, then I think we can start to figure out how we do all the things that we humans like to do, but do it in a way that is planetarily sustainable. So we'll leave it at that.
Thank you, Brian. And so that brings up a great point when I'm going to ask Kim to talk about too. And we mentioned this. So a few years ago, our community got together, a number of us, to say we need a greenhouse gas assessment. It's like, where are we, to understand a lot of that science so that we know, what gets measured gets managed. To do that, to create goals around reduction of that carbon and strategies to achieve those goals. Can you tell us about the collaborative and the plan, Kim?
Yeah, and I'm not the only one. I'm sure there's many of you out there who are involved with the Climate Action Collaborative who could do a great job of being up here. But thank you for having me, and thank you for inspiring me. It's really great to be up here and see all of you out there. We've had the plan for 3 years now, like you said. We created a plan. We've got a roadmap. We've broken it down into many, many doable things we can do. You can do, and we can all do together. And we've got a mobility, transportation section. We know what we need to do there to certain degrees. We have landfill and waste. We have energy supply. Thank you so much for helping us with that. We have buildings, energy efficiency. We have a roadmap. How much of it have we gotten accomplished? I'm so sorry. I feel so bad. Yesterday, I was at a Vail Town Council visioning retreat, just kind to set the future. And I said, I know we're supposed to only think in terms of, what's doable in the next 3 years, but I just want to say, let's think about 50 years. 50 years from now, what's it going to be like? Because our town is 50 years old now. We might not have skiing. We probably won't have a ski town. And how did that make me feel? I was being radical, right? Nobody really wanted to hear that. I need all of you to be leaders and to give me your resolve. Come to our town meetings. Ask us to do these things in the Climate Action Plan. We all need to do this together. I can't do it alone, but we have the roadmap. You talked about the Drawdown. Climate Action Collaborative is working on, okay, what if we do this? Where should we put our resources? But we don't want to get stuck in analysis paralysis, right? We have the information we need in many of these sectors. We know what we need to do. We just need to do it together. And I think it's a very simple thing to say. But what I'd really like to see is for all of you to wake up tomorrow morning and say, well, when's my next town council meeting that I can go to as a participant, and what would I like to address? How would I like to work with my community members to bring an agenda forward so that we can get something done here? We have goals in our plans, but we don't feel that sense of urgency as elected officials. I'm saying, I feel a sense of urgency, but we have so many things coming at us all the time. You showed those, all of those, and they're out there. And I feel like we're constantly just trying to put out fires left and right. So we really need to make this more of a focus. As an elected official, how do you feel about this? You're in a similar situation, maybe.
We are as elected officials, and I think we are. We mentioned that we tried to fill this room with leaders, and you are elected officials, and you are business leaders, and you lead emergency management areas, and you are legal experts, and you are climate activists. All leaders, and we keep talking about that. It isn't leadership that gets it done. It's leadership that makes it possible. There was another something that I took away. Rob, did you see all of the ski industry people talking? They had the 3 largest ski recreation companies, including Vail Resorts. So Kate Wilson was there from Vail Resorts. She's the sustainability manager for the corporation. And she just told the story just kind of as an aside. Vail has done remarkable in setting goals and getting close to achieving many of those, achieving some of them. And when they were getting close, Rob Katz said to her, welcome aboard. We need to set new goals. We're getting close to ours or achieving some. So go tell me what this is going to look like. So Kate goes out and does her research and figures out what she thinks that the company can get done, what she thinks is viable within a publicly traded company, and gets this all together and gets Rob in the room with everybody who helped work on it, and they give this presentation, and at the end of it he said, That's great. They had, I think, previous goals. I can't remember the numbers, maybe 50% renewable and waste diversion, and now we're going to shoot for 75. Whatever that extension was, it was 75%. And he said, great, why not 100? And effectively, the answer is, well, because you haven't walked in the room and said, why not 100% yet? You should have told me that from the beginning. So they went right back out and said, all right. The difference is we just don't know how we're going to get there. And it's still the goal, 100% waste diversion, 100% renewable energy. So when we were putting this thing together, we have a whole bunch of people coming from Eagle County staff. And Amanda Bay just said, we're like, everybody come to this thing. We're trying to put this event together, not thinking we're sending a whole bunch of cars. Amanda said, hey, we own EcoBus. Can we get a bus to bring us all there? Like, yeah. So then that just happened. Everybody got on board. It's that leadership, it's that permission. The people who can make this happen are everywhere. It's all of us. But we have to give them permission. We have to make it possible for them to act. So we could sit up here, I think, all night and talk about this stuff. We want to be respectful of your time. We have a number of things set up outside, including some delicious, sustainable food that we hope you'll stay for. And there are some booths including Holy Cross's Pure program, which you can sign up for if you're a Holy Cross customer. So I hope you'll go out there too. I do want to do a couple of things, thanking some of the people who made this thing happen. It was my fellow county commissioners, it was Adam Palmer at our Sustainable Communities Department, certainly Sarah Smith-Himes and Eric Heil from Avon, Kristen Bertulia, absolutely Kim Schlepfer, and a lot of people I'm leaving off that list because it is a long list. And I want to thank our panelists here and Rob for bringing this message and hopefully getting you into this same position that we left Park City in, was the state of excitement, because it's now difficult, but it's simple. If it doesn't answer the carbon question right, toss it aside and look at something else. It's simple. And I'm a simple person. So I hope that you leave this energized tonight and together help us all answer that question for our community, what now? So thank you all for coming tonight, and we hope to see you out in the foyer for further conversation.
Thank you.